A complete guide to understanding Kubernetes, cheat sheet narration. 1. How developers see Kubernetes. The journey begins with developers who create applications and need to deploy them. From a developer's perspective, Kubernetes serves as an abstraction layer that simplifies deployment. They interact with development environment, where code is written and tested, container images, applications packaged with their dependencies, deployment manifests, YAML files that describe how applications should run, and service definitions, how applications communicate with each other. The developer workflow flows from code creation through containerization to Kubernetes deployment, where the platform handles the complexity of infrastructure management. 2. Kubernetes architecture. The architecture reveals the sophisticated orchestration system beneath the surface. Master node components. API server, the central management hub that processes all requests. etcd, the distributed key value store that maintains cluster state. Controller manager ensures desired state matches actual state. Scheduler decides which worker nodes should run specific pods. Worker node components. Kubelet, the node agent that manages pod lifecycle. Kubeproxy handles network routing and load balancing. Container runtime actually runs the containers, Docker, Containerd, etc. Additional elements. Pods, the smallest deployable units containing one or more containers. Services provide stable networking for pods. Ingress controllers manage external access to services. 3. Top Kubernetes resources, the essential building blocks that make Kubernetes powerful. Core workload resources. Deployments manage stateless applications with rolling updates and scaling. Stateful sets handle stateful applications that need persistent identity. Daemon sets ensure specific pods run on every node, like logging agents. Jobs, cron jobs, handle batch processing and scheduled tasks. Networking resources. Services provide stable networking for pods, cluster IP, node port, load balancer. Ingress manage HTTP/HTTPS traffic routing from outside the cluster. Network policies control traffic flow between pods. Storage resources, persistent volumes, PV, cluster-level storage resources. Persistent volume claims, PVC, user requests for storage. Config maps and secrets manage configuration data and sensitive information. 4. Request flow in Kubernetes. The journey of a typical request through the Kubernetes ecosystem. External request, traffic enters through load balancers or ingress controllers. Ingress processing, ingress controllers route requests based on rules, host, path. Service discovery, requests reach services that act as stable endpoints. Load balancing, services distribute traffic across healthy pod replicas. Pod processing, individual pods process the requests. Response path, results flow back through the same path in reverse. The flow demonstrates how Kubernetes abstracts the complexity of microservices communication, providing service discovery, load balancing, and health checking automatically. 5. Horizontal pod autoscaling, HPA. Kubernetes intelligent scaling mechanism. Monitoring phase. Metric server collects resource usage data, CPU memory. Custom metrics can include application-specific metrics. External metrics, integration with monitoring systems like Prometheus. Decision phase. HPA controller evaluates current metrics against target thresholds. Scaling algorithm calculates desired replica count based on resource utilization. Cooldown periods prevents rapid scaling oscillations. Execution phase. Deployment updates modifies replica count in deployment specifications. Pod creation and termination, Kubernetes schedules new pods or gracefully terminates excess ones. Load distribution, services automatically include new pods in traffic routing. Feedback loop, the system continuously monitors and adjusts, creating a self-healing and self-scaling infrastructure that responds to demand without manual intervention. Key takeaways. This cheat sheet illustrates how Kubernetes transforms complex infrastructure management into declarative automated operations. It shows the progression from developer intent through architectural components to automated scaling, demonstrating why Kubernetes has become the de facto standard for container orchestration. The visual representation emphasizes that while Kubernetes appears complex, it follows logical patterns. Developers describe what they want, the architecture determines how to achieve it, resources provide the building blocks, request flows ensure reliable communication, and autoscaling maintains optimal performance.